This video is for anybody that's still struggling with how to do the mole Airlines project. The first thing I'm going to recommend is if you're not comfortable solving empirical formulas from percent compositions, you'll need to go back to the Thursday lesson from empirical formulas. That was back last Thursday in the module on Canvas. And you need to watch that first video and then read those notes. I really want you to look at that if you haven't figured out comfortably how to do empirical problems. If you know how to do that and you're just kind of confused with this project, then this video is going to help you work a few examples and kind of show you what to do with the data. Now with this project, you're given all this information here. There's a scene of a crash. There's some information about percentages of a substance that was found at the scene. And you can see here we have carbon, hydrogen, nitrogen, and oxygen. And then you're given percentages. In the real world, chemists can take substances and then run them through a machine that will separate the components based on how fast they move. And it can actually create the percentages for those, and we can use those to create an empirical formula. And then if we know that empirical formula, which is just a ratio of the atoms within the compound, then we can actually identify those substances. So what we're doing here is we're doing the job of a chemist that's been given the percentages just like this right here. And our goal is to figure out what this compound represents. And we're going to work through a few examples to show you how to do that. Now down here in the description of your job, what this is showing you here is there's 4 different data things that we're going to be looking at today. Table 1, Table 2, Table 3, and then your data sheet. The first one I want to show you real quick is Table 1. And this is actually going to show you the percentages of those different compounds that were found on the different victims. For instance, passenger 1 had a substance that was found in their blood with these 4 percentages. Carbon had 67.31, hydrogen 6.98, and so on. Your job is to figure out what this substance represents by doing the math for the empirical formula steps. On Table 2, this actually has a list of different substances that those formulas can match. In the real world, a chemist would have a computer database that would have thousands and thousands of different compounds that these substances could be. And it would be the chemist's job to try and match them up to what those substances' identities most likely are. For you, we've gone ahead and narrowed the list down to the things that are going to appear. So if your answers aren't found on this list, it means that something's wrong with your calculations. On Table 3 here, this is some data that the investigator has collected from information that was provided before the crash. And this is just different information and notes about the different victims. Your job is to figure out the identity of the victims by comparing the substances that are found on that victim or that passenger and then comparing it to the note sheet. And I'm going to show you one example of how to match that up. And then the final thing here, this is your collection of your information. Once you know what each substance is, and then you can identify that person, this is part of that final thing that you're going to be turning in. What we're going to do right now is we're going to work an example of the very first passenger. I'm going to show you how to do that right now. Now remember, I told you to watch that video from Thursday first before attempting this assignment. So if you haven't watched those notes from Thursday, go back and look at that because that's going to walk you exactly through the steps of how to do the empirical formula problems. I'm going to be going pretty fast here through that. So if you need to slow down at any point, you can pause the video or you can go look at the notes from Thursday because all of these slides that I have right here, these are pulled straight from the notes page on from empirical formulas back on Thursday, and we did that. So on here, these are the 5 steps that you're going to be using, and this is simplified with this very short poem. Step 1 is percent to mass. Step 2 is mass to mole. Step 3 is divide by small. And step 4 is multiply until whole. Those steps are going to make sense if you go back and read these 5 steps to solve an empirical formula problem. I'm going to be talking about step 4 specifically on the second example that I work because step 4 is really what confuses students a lot of times. This is where you have to multiply by a number because our empirical formula by definition is the simplest whole number ratio. An empirical formula tells you the ratio of the atoms within a compound. And that's why, if you still don't know what an empirical formula is, you really need to go back and look at those notes from Thursday first, and then proceed with this video. We're going to work example number 1 on the first passenger, and we're going to use these 4 steps to do that. I find that notebook paper a lot of times is really an easy way to keep track of our information, and it helps with kind of organizing everything. So I like to do my problems on notebook paper, and that's what I've got a simulated notebook paper there for you on the screen. First thing I'm going to do is write down my 4 elements that we're working with. Every one of these problems is going to have some combination of either carbon, hydrogen, nitrogen, or oxygen. So what I'm going to do here first is on the first line, I'm going to write carbon, or a C, and I'm going to skip a few lines to leave some space within there. And I'm going to write my next element, which is H. And then I'm going to write N after I skip a few lines. And then finally O. And then if we go look at table 1, the percentages that we said were 67.31 for carbon. Hydrogen was 6.98. And then nitrogen was 4.62. And oxygen is 21.10. And again, these were the percentages that were pulled straight from table 1. Now, if we look at our formula there for the steps, step 1 is percent to mass. Now, these are the percentages. What we're going to do is we're going to assume out of a 100-gram sample, that's what we're going to assume that we have. So 67.31% of 100 is just 67.31 grams. All we have to do here, instead of writing a percent sign, we're just going to write G for grams. That's going to be our mass. So step 1, percent to mass. Instead of writing a percent sign, I'm just going to change it to grams since we're assuming it's out of 100 grams. And that keeps the percentage and the math easy. Step 2 is mass to mole. The way we're going to do that is we're going to need to go to a periodic table. Now I've got one pulled up here on my computer. If you just Google one on the internet, or if you already have one, then you can look up those masses. So our mass here for carbon is 12.01. For hydrogen is 1.01. Nitrogen is 14.01. Oxygen is 16.00. You're going to be using those same problems every single time. And that's what's going to be easy for this. We're never going to use any different elements since they're all some form of carbon, hydrogen, nitrogen, or oxygen. So that second step was percent or mass to mole. And we're going to divide by the molar masses. I like to use the train track setup that we've done so many times at this point. So I'm going to bring grams down to the bottom. And then that mass for that was 12.01. And then up here, I'm going to write 1 mole of carbon, since that's what we're working with here. And then we're going to do the same thing for these elements down here. Hydrogen, sorry about that line, is 1.01 grams to 1 mole of hydrogen. And then down here, nitrogen is 14.01 grams up to 1 mole of nitrogen. And remember, these numbers are coming straight from the periodic table. These are the molar masses, which is the same thing as the atomic mass. And then oxygen is 16.00 grams to 1 mole. Remember, for dimensional analysis, we multiply across the top and divide by the bottom. So really all these are in the calculator is the top number divided by the bottom number, since we don't really need to multiply by 1. When you plug those into the calculator, you are going to get 5.60 for carbon. And then hydrogen is 6.91. Nitrogen is 0.33. And oxygen is 1.32. 1.32, just like that. Now that third step on here is divide by small. We are going to go through and divide by the smallest number that we have. This right now shows the ratio of our elements, but the problem is we need a whole number ratio for our empirical formulas. We don't really have 5.6 of an atom or 6.91 of an atom. We need to get these numbers here to whole numbers. And the way we're going to do that is we're going to divide by the smallest number, and that's going to help get us to a whole number. Now, of these four choices, 0.33 is the smallest. I'm going to go in here and write divided by 0.33, and we're going to do that for all four of these. Just like in math class when you're working on an equation, if you do one thing to one number, you have to do it to all of them. That's not going to change the ratio if we do it to all four the numbers here. When we enter these back into the calculator, we're going to get four different answers. First one is going to be 16.97. The second one here is going to be 20.94. Third one here is going to be 1. And then the fourth one here is going to be 4. One thing that I forgot to mention is that you really want to carry everything to at least the 100th place if we're when we're working these problems, because that's going to help make sure our numbers are accurate and precise in the end. So always carry things out to the 100th, unless when we divide by small in this final step, when you get a whole number, that's fine here. But what we're going to do now is we need to check and see if we need to multiply until whole, and that's step 4. This is where I said a lot of students will get confused. We go back to our notes over here. This table shows you the different numbers that we can have. So what you're allowed to do is after you've done step 3 and you've divided by small, your numbers, you want to check and see what those decimals are. And if they're close to any of these numbers in the chart, you're going to need to multiply by the respective numbers to make it a whole number. If you notice on our example we just worked, 16.97, that decimal 97 is closest to 0. It's not close enough to 0.75. It's too far away from that. That 0.97 would round to 0. And if you see here, if a number ends in 0, there's no need to multiply since it's already going to be whole. When we look at our numbers here, both of our first two elements are going to round to the nearest number. They're both going to round up to 0. So that one, 16.97, we're going to say is about 17. It's close enough that we can round that. 20.94, we're going to say that that's close enough to 21. Now, these numbers, 17, 21, 1, and 4, those represent the ratios of the atoms within that compound. We've done our math. We now have our formula. We're going to match that up with C17. That's how we write that one. And then H21. N1, which we typically don't write the 1. And then O4. Now that we have that formula, C17, H21, NO4, what we can then do is go to our table 2, and we can find that formula on here. C17H21NO4 is this formula right here. That is the formula for cocaine. That's going to represent the empirical formula for that substance. Now that we know that identity of the substance, our next goal is to figure out which passenger possibly had the cocaine on them. On table 3, this is your collection of notes that the investigator has collected for you. This was all the information available prior to the plane. And this has all the different people on here. If we read the different descriptions, your job is to figure out which of these people might have possibly had the substance that you just calculated. If we look right here on Mario Yogati Mims, we can see that he's a rapper. Songs and albums frequently reference cocaine, including one called Pure Cocaine. Was headed to LA to promote his newest album, Live from the Kitchen, a relatively new celebrity with no public feuds. We could take our guess and say that Yo Gotti is probably the one that's going to have cocaine. What I would recommend doing first, when we get to our final collection here, is for the victims, as we're working the data here, you can write down that victim 1 had cocaine, and then you can continue and do all the other substances here, and then go back and do the victims. That's probably going to be the easiest thing, because you might have 2 different victims that possibly might have the same substance on them. For example, if we just calculated cocaine here, you might see multiple descriptions that fit that. So it might be easier to do all of the calculations first before you start trying to pinpoint who did it. What we're going to do next is work one final example from here, and I'm going to use the numbers for victim 2, but we're going to work only this first one. So since there's 2 different substances on victim 2, you're going to need to work 2 different problems on here. And we're going to work that right now on this victim 2. If you notice for victim 2, there's a difference here because there's only 3 different numbers on this one. So there's no nitrogen if you go back and look at the list. I'm going to write my elements, and we're going to skip nitrogen since there wasn't a number for that. And on that table 1, it tells you the percentages were 63.15 for carbon, hydrogen is 5.30, and then oxygen is 31.55. And then remember, step 1 is percent to mass. We can get rid of our percent sign and we can just go ahead and change it to grams since we're assuming we have a 100 gram sample. And then we're just taking a percentage out of 100. Percent to mass is step 1. Step 2 is mass to mole. I'm going to divide by those molar masses. Remember, we got those from the periodic table in the last example. You won't have to look it up each time. Oops. Sorry about that. You won't have to look it up each time because it's just going to be the same numbers for all those problems. Carbon, we said, was 12.01 grams to 1 mole of carbon. And then hydrogen was divided by 1.01 to 1 mole. And oxygen was divided by 16.00 to 1 mole. When we go through and do our calculations for that in the calculator, you should get 5.26 for this first one. Second one is going to be 5.25. And then the third one is 1.97. Now, third step says divide by small. We're going to look for our smallest answer of these 3. And in this case, it's 1.97. So we're going to write divide by 1.97. Remember, you have to do this to all of the different problems here, or all the different numbers. Divided by 1.97. When we go back into our calculator work, this is where we're going to get our different answers. And for this one, this first one, it's 2.67. The second answer here is 2.66. And then the third answer here is 1. Now we're at step 4. This is multiply until whole. And this is the step that I said a lot of students will get confused on because they're not quite sure what number to multiply by. If we go back and look at our chart from the notes here, we can see that anytime a number ends close to 0.67, and if we look at our work we just did, both of these numbers here are close to 0.67. That's the closest decimal that those represent. And if we look on the chart, it says when a number ends with 0.67, we can multiply that by 3, and that's going to get us close enough to a whole number. And when we look at that for our example here, we're going to do that for all 3 of these numbers. Remember, if you do one thing to one, you have to do it to all of them. So we're going to multiply all of these numbers by 3. Because remember, we can't have a 2.67 of an atom. That's our goal here, is to get it to a whole number. And multiplying by 3 is going to allow for that to happen. 2.67 times 3, whenever we multiply that out, is going to be 8 for this one. This is also going to be close enough to 8 that we can round that to. And then last one here is going to be 3. We now have our formula, C8H8O3. And if we go back and look at our substance list on table 2, we can see that C8H8O3 is going to be right there, vanilla. And then we can go back and we can read our descriptions again and figure out which person might have had vanilla. But you need to remember, for passenger 2, they have 2 different substances that were found on the first one. Vanilla was found on their face. And now you'll need to go back and do that second calculation for passenger 2. Now, when you look through all these, you should have a total, I think it's 19 different problems total that you're doing, because you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So by the end of this, you should have done 19 total problems. Easiest way, like I said, is do it on notebook paper, and then you can just submit a picture of that to show all of your work. If you're still having trouble, please reach out to your teacher and ask them, and we can walk you through how to finish these problems. But good luck to you.